Right, so back to the videos. This is about global warming, guys. So we've done the greenhouse effect, this is about global warming. Now, I'm going to show you first of all a very crude graph that I've drawn on the board here. It's a representation of something you could get given during the exam. Now, what it's going to show is it's going to show a temperature change in degrees Celsius. This is a global temperature change, and it's going to look at years where we are now, 75,000 years ago, 150,000 years ago. And it's got two things that it's showing on here. Well, this here is the temperature. So this is how the temperature has fluctuated over the last 150,000 years. And the red one here, well, this is CO2 levels. So these are atmospheric CO2 levels. Now we know this from ice cores. So ice cores can tell us what the CO2 levels have been and the global temperature. So that's how we can find out that. Now the CO2 levels and the global temperature, you can see that there's a correlation here. There's a positive correlation. As one changes, the other one also changes with it. Now, you can see that the CO2 levels have not been steady throughout the last 150,000 years. They've fluctuated up and down, up and down, up and down, and so does the global temperature. Now, I haven't finished that graph because what I actually want to show has happened recently. You can see the temperature has gone up and then kind of leveled out. But what actually happened at the moment is that the CO2 levels absolutely spiked to highest levels that they've been in the last 150,000 years. So that is looking at a very broad time period. You could also look at this across quite a narrow time period. So for example, maybe the last 150 years. So I could wipe this out and take it a little bit closer into the current time period we have been, not the last 150,000 years, but you can see the correlation that we're seeing there. So if I take that off, and again this is going to just be a broad representation, now I take off the time period here, okay, so instead of 150,000 years ago, let's go up to the current position here, and let's go back to, say, for example, the 1880, around about that time there. Okay. Now, what we're seeing here is that there's been a trend, quite a big significant trend in the increase in CO2 levels. So CO2 levels have started to increase, like so. And what we've seen is a knock-on effect. So what we've actually seen is, well, this could be represented in various ways. You could actually have bar chart, for example. Let's use a green pen for this. So that's your CO2. So these are your CO2 levels. So you can see CO2 levels have risen over the last 140 years. So that's my CO2. Now, if I look at average global temperature, okay, we can see this is a bar chart saying that it is been decreasing at this period here, but we've seen that flip around. What we've actually seen is started to see increases in temperature, and that's being consistent throughout the last, say, about 70 years, where the temperature has started to increase rather than decrease. So as the CO2 levels have increased more recently, we've seen the Earth's average global temperature also increase. And there's a lot in the press about this. I'd be amazed if you'd fail to see press articles or on the news about global warming and about how the average global temperature is rapidly increasing. And we'll get on to what the consequences of that could be a little bit later. But again, there's a correlation between CO2 levels rising and the global average temperature rising. Now, thinking about why that has happened. Why has there been a sudden huge spike in CO2 levels? What's actually caused that? Now, if we're looking back at 1880, some of you should be starting to think about the Industrial Revolution. Industrial Revolution meant that we started to mine huge amounts of fossil fuels. I'm talking coal here, I'm talking oil, I'm talking natural gas. We started to mine these, and we started to burn them. So we started to look at, and you saw from that little clip there that I showed you, the montage of photos, we're starting to burn fossil fuels. We burn fossil fuels, or have burnt fossil fuels, for energy, for our power plants, for our energy, for us, for consumerism, and both in terms of factories as well to make things. We have put fossil fuels in our cars and our vehicles and our aeroplanes, and we've burnt them. We have seen large-scale deforestation, and we've also seen burning of forests, not just chopping them down, but also burning of the forest and the wood as well, which is a double whammy. That has led to carbon dioxide levels increasing, and I'll get into why that is in a moment. On a side note, one of the other greenhouse gases that we also talked about is methane, and methane levels have been increasing as well. Now, why have methane levels been increasing? Well, first of all, there's more people, and more people need feeding, and feeding invariably means cattle, means farming, for dairy, for meat, and those cattle produce methane. They produce methane from their excrement. So that has massively increased the amount of methane in our atmosphere because of farming. Now, other things that have increased methane are down to things like waste and rice fields that have also increased the amount of methane released. So both those greenhouse gases have been increasing because of human-led factors. Okay, we have led to those gases being increasing in our atmosphere. So I'll just quickly go through some of the key ones for carbon dioxide, and I'll just drop down some of the key ones for methane. So carbon dioxide to start with. I talked about burning fossil fuels. Absolutely. So reasons for CO2 levels rising. Number one, we'll do CO2 first. Number one, burning of fossil fuels. Now I'll just do a general equation here for us just to remind ourselves. Okay. Now fossil fuels, crude oil topic, hydrocarbons. So let's just pick a general formula, CXHY, to represent our fossil fuel. It's carbon and hydrogen, so hydrocarbon, plus oxygen is going to produce CO2 plus H2O. That is combustion. And that's complete combustion if we're being a bit more specific, because we've got carbon dioxide and water. So I'm producing carbon dioxide by burning my fossil fuel, so that's number one. Number two, we've also got deforestation. So we've also got deforestation. Now that could be, as I say, a double whammy. First of all, you can cut the trees down. Well, if you cut the trees down, think about what plants and trees do. Photosynthesis. They use carbon dioxide in the process of photosynthesis. So if we chop them down, they're no longer able to do that. So if you think about the equation for photosynthesis, we've got CO2 plus, we've got H2O, and we're going to be making C6H12O6 plus oxygen, 6, 6, 6. So there's our photosynthesis. So if we chop down the trees, photosynthesis can no longer occur in those trees. That means CO2 is not being used up or stored, and also actually oxygen is not being produced. Now, when I said earlier it was a double whammy, if I take those trees and I cut them down, yes, they can no longer use the process of photosynthesis to store carbon dioxide. Well, they also be burnt as well. So a lot of the trees that are cut down are then burnt on site. Well, if you burn them, you're also then releasing more carbon dioxide because you're effectively burning a fuel, and then you're releasing carbon dioxide as well. So it's a double whammy with deforestation on that side of things. Then the other thing we've got is your methane. So, like I said with the methane, we've got increased farming, which releases methane, and we've also got increased waste. So waste produces methane as well. So like rubbish tips, dumps, all the rubbish that you produce and goes into a black bin and gets put into landfill, it rots and releases methane. So the waste produces methane, cattle produce methane, and rice fields also produce methane, and we need more rice fields as the population grows, we need more food. Naturally, swamps produce methane as well. So those things are being, those greenhouse gases are increasing due to those human factors. Now, what does that link into global warming? Well, if we have more of the greenhouse gases, such as CO2, then that greenhouse effect that I talked through earlier is going to be exaggerated, because there are more of those molecules of carbon dioxide in the atmosphere. Therefore, there's a greater chance of the long wave radiation coming into contact with that carbon dioxide molecule and that heat being trapped. So if we increase the number of carbon dioxide molecules, if we increase the number of methane molecules, the effect of the greenhouse effect is going to be exaggerated. Therefore, the global average temperature will increase. Now, I have included a little 3-minute animation on this, and I really like it because it just relates it basically to pinball. If you ever played a pinball machine, when you're trying to fire the pinball out, basically it says that if you add more obstructions to it, it's going to make it harder and harder for you to get rid of that pinball. And I think it's a really good animation, actually shows that. So that's what's leading to global warming. And global warming is the rise in the Earth's average atmospheric temperature. Again, I'll put definitions that will come up on the board here. So that's looking at the greenhouse effect, how it works. It's looking at global warming, how that's happening because of an increase in greenhouse gases. Now, what's going to happen in the long-term run, we'll get to the effects of global warming in terms of climate change, is very difficult to predict. The Earth's weather system and climatic system is very, very complex. So we cannot predict with certainty what's going to be happening in the next 25, 50, 100 years. There's very complex models, but we cannot predict with absolute certainty because the Earth's climatic system is far too complex to do that. So that's just a little side note for you to be aware of. Next video I will do will be on climate change, and just some of the key things that could happen based on global warming.